Hello and welcome to Math 1000 Probability. So, before we get into probability, we need to talk about counting just a little bit. So, with counting, we need to understand like that there's different ways to count objects. And the first starts with the basic fundamental counting principle. It's basically just multiplication. All right? If you have values, the number of options, you just multiply them across. For example, a restaurant offers 10 appetizers and 15 main courses. In how many ways can you order a two-course meal? That is literally 10 times 15, 150 options. Similarly, a pizza can be ordered with two choices of size, medium or large, three choices of crust, thin, thick, regular, five choices of topping, ground beef, sausage, pepperoni, bacon, mushrooms. How many different one topping pizzas, all right, can be ordered? Well, that means two sizes, three crusts, five toppings, 30 options. What gets more interesting, all right, is when you are taking, right, when you have lots of options and more things are happening. So we're taking a multiple choice test that has 6 questions. Each question has 4 answer choices, A, B, C, or D, with one correct answer per question. If you were to guess on each question, and how many ways can you answer the question? So the idea here, right? There are 4 options on question 1, 4 options on question 2, question 3, question 4, question 5, and question 6. When things are multiplied over and over again, I could write this as 4 to the 6th power. This leads in to what is known, all right, as the power rule. So counting really breaks down, all right, and I showed that because counting really breaks down, all right, into asking a few questions. The first, are repeats allowed? If the answer is yes, all right, we end up with what we just had, which is known as the power rule. If the answer is no, that breaks in. Then we need to ask another question. Is order allowed? And that will break into 2 additional categories. If order is required, that's a permutation. If order doesn't matter, that's a combination. Also referred to as NPR and NCR. That's basically the calculator commands. So this first situation, notice what we had, right? Multiple choice. Are repeats allowed? Yeah. I can guess A and A and A and A on all 6 questions. So that's why this question here, all right, is a power rule example. All right. Before we get into permutation and combination, we need to talk about factorials. So factorials in the calculator, all right, math, PRB, or prob, depending upon what your calculator is, but it's basically probability. Uh, and the commands here are, right, in case you hadn't noticed up till now, are TI commands. So the factorial command is basically just that value multiplied by itself reducing. So for example, in how many ways can you arrange 5 books along a shelf, assuming that the order of the books makes a difference? So notice no repeats are allowed here because once you place a book, I can't place that same book again. This is why, all right, this is 5 factorial. The other way to do this, right? I have 5 books. All right. I put that first book in one of the 5 books in the first slot. Then now I have 4 books. That goes in the next slot. Then I have 3 books. Then I have 2 books. Then I have 1 book. That's what a factorial is. It's the reduction, all right, of that value times itself minus 1, all right, all the way down. And then that becomes 120 ways. This leads into permutation, and as above, all right, when you do not have repetition, and order does matter. Without repetition, order does matter. Now, again, we have the commands here, but NPR is the command we are going to use. You can do this calculation, all right, and also you can do this with what is known as the blank method, where you basically just fill in the values and reduce it down. And actually, I like that better in a lot of cases. So, how many 3-letter code words are possible using the first 8 letters of the alphabet? All right, if no letter can be repeated, well, by definition, no repeats. All right, that means that we go down the right side of this tree, and order does matter. So right, then left, and oh, look, we're in a permutation. I also like this because I can just do this with what is known as the blank method. 3-letter code words, that means I have 3 blanks. So no letter can be repeated. Well, I started with 8 letters. Well, now I have 7 letters and then 6 letters. 8 times 7 times 6. You can also do this, all right, as the permutation 8 NPR 3. So both of these are the same, and it comes out to 336 words. If letters can be repeated, well, this is the power rule. The power rule can be done with the blank method as well. 8, and then 8, and then 8. Right? With the power rule, that is literally 8 to the 3rd. That gives 512 words. We're pretty loose with the word, the word words, right? Serial numbers for a product are to be made using two letters followed by 3 numbers if the letters are to be taken from the first 8 letters of the alphabet with no repeats, and numbers from the first 10 digits, no repeats. How many serial numbers are possible? So again, 5 blanks, 2 letters. So first 8 letters, that's 8 times 7, and then followed by 3 numbers, 10 times 9 times 8. 40,000 plus ways that can be accomplished. So, a corporation has 7 members on its board of directors. In how many different ways can it elect a president, vice president, secretary, treasurer? So here's the big thing. Notice this one didn't explicitly say like the last problems. It didn't say, oh, order, no repeats and order matters. But this is people. So one big thing with people, usually you can't have repeats with people because once you select a person, you can't put them back in and then select them again. Order then also, I can recognize order matters here because we have distinct positions, president, vice president, right? Those are usually not interchangeable, okay? Also, this is kind of along the same lines as first place, second place, third place, like in a race. First and second place are not the same, right? So order matters in that sense. So that's why this is a permutation. No repeats. Order matters. So again, multiple ways I can do this. I could do this with the blank method. All right. Or this is 7 NPR 4. Again, calculator command. Sometimes it kind of looks like this in the calculator too. Doesn't really matter. All right. Check it out in your calculator, and you should end up with 840 ways when you do the calculation. Duplication of items. So the other nice thing about factorials is when you have repeated things occurring, you can reduce that number of repeated options. Words, all right, are the big one here. So, in how many ways can the letters of the word Mississippi be arranged? The idea is there are 11 letters in the word Mississippi. So that would be 11 total possibilities. Then you reduce the number of repeats. All right. There are 4 S's. There are 4 I's. There are 2 P's and 1 M. Notice the numbers in the denominator. 4 plus 4 plus 2 plus 1. That makes 11. That number in the denominator always needs to end up as the number in the numerator. Then I could calculate that out, and I would get 34,650 ways. Let's do that again. Osmosis. There are 7 letters. All right. Let's see. There are 2 O's, 3 S's, 1 M, all right, and 1 I. All right. 2 plus 3 plus 1 plus 1, that makes 7. Now, be aware, 1 factorial is just 1. All right, so I'm writing the 1 factorial, all right, but it doesn't need to actually be there. 420 ways, that is possible. All right, last branch on our tree here. Okay, so repeats, when there are no repeats allowed and order does not matter, this results in combinations. Combinations are actually the most common type of counting because a combination is when order doesn't matter. And in so many cases, order does not matter. Cards being the biggest one. And let's take a moment to make sure we understand a deck of cards. Also, as a note, here's again the formula. It's the NCR command in most calculators. All right. Casio, TIs, all right. Generics that I've seen, NCR tends to be the command. Again, you have this command with factorials, but this is one thing. Look up how to do it in your calculator. Okay, sorry. Back to a deck of cards. So a deck of cards has 52 cards in it. 4 suits. Hearts, diamonds, spades, and clubs. All right, these are the black, half the cards are black, half the cards are red. There are 13 cards of each suit. They go, all right, ace, 2, 3. All right, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, king. These are the face cards, all right? There are 12 total face cards in a deck. And ace typically represents 1 or 11, all right, in regard of how, I mean, blackjack definitely, but usually in counting, ace can be high or low. So it can be after the king, all right, or below the 2. I say this because we do a lot of things with cards, and the fact that people don't understand a deck of cards is truly tragic. To that end, all right, in poker, a person is dealt 5 cards from a standard 52 card deck. How many different 5-card poker hands are possible? So here's the big thing about cards. Usually there's no repeats. Once you get dealt a card, you don't put it back and then get dealt a card again. Okay? So once you're dealt a card, it removes it from the deck possibilities. Here's the other big thing. Order doesn't matter. Because the idea is that if I got a king, if I was getting 5 cards, if I get a king first or I get a king last, it doesn't matter. I have a king. Okay? It doesn't matter where in my hand it came. So that means this is the definition of combinations. So if I have 52 cards, NCR 5. That gives me 2,598,960 hands. That's the whole thing. That's why a deck of cards is so interesting. All right. 52 cards. But because of the distinctness and the interesting situation of the cards, 2.6 million hands from 52 cards. That's really, really interesting. All right. From a committee of 10 people, in how many ways can we choose a chairperson, vice chairperson, a secretary, assuming one person cannot hold more than one position? So, once again, all right, order. Sorry, no repeats. And in this case, order does matter. That means this first situation is a permutation. So that would be 10 and PR 3. 720 ways. In how many ways can we choose a subcommittee of 3 people? Now, notice here, subcommittee, that means that I'm just selecting a committee of any 3 people. So once again, no repeats. This is humans. All right. Order does not matter. That's a combination. Because if I'm just selecting any 3 people, it doesn't matter if I get selected first or third, I ended up on the committee. So that's 10 and CR 3, which is 120 ways. And lastly, in how many ways can we choose a president, vice president, and secretary if more than one position can be held? So like I said, usually with humans, repeats are not allowed unless something like that is explicitly specified, because that is saying repeats allowed, which means that is power rule. So notice, all right, this was actually this went through every possibility of this chart. All right. All right. A company has 7 senior and 5 junior officers. An ad hoc legislative committee is to be formed. In how many ways can a 4-officer committee be formed? So that is composed of four different questions. So once again, this is humans, and I don't see anything explicitly talking about more than one position held. So no repeats. And then we're just creating these various committees, which means order does not matter. Which means that everything we're looking at here, combination. So any 4 senior officers, well, that means we have 12 people. NCR 4. All right, 4 people from the 12 officers. Doesn't matter which officers. If I want 4 senior officers, well, I only have 7 senior officers, and I want 4 of those senior officers. That means 7 NCR4. There's only 35 ways to do that. 3 senior, all right, and 1 junior officer. Well, again, I have 7 senior officers. I want 3 of them. And I have 5 junior officers, and I want 1 of them. Now, the important thing is, if I'm doing these 2 combinations, I'm multiplying these together. So it's that number times that number. And then just writing that out so you can see the multiplication. This does remind me. So notice, right? We got 4 in the question before. We got 4 members from the 7 senior members. That means that, just FYI, that was 35. We selected 0, all right, junior officers from the 5 junior officers. Be aware, there's only one way to do that. And that was actually hidden in this calculation here, because 35 ways to get 4 out of 7, all right? But there's only one way to get 0 people, right, out of 5 people, all right? You select 0 of them. That's the one way. So just so you're aware, technically that calculation in B is multiplied by 1, but I don't even show it because there's only one way to do that. Also, if you ever do it in your calculator where you, just a note, I see people do this, like things like this all the time. 5 NCR, like 10. If you put this in your calculator, it will get out 0. Because this is basically saying, I'm trying to select 10 people from 5 people. That is impossible. There's 0 ways to do that, right? So just as a note, all right, your calculator's not making a mistake there. It means that you messed up your concept. All right. Lastly, 2 junior officers and 2 senior officers, just like the previous one. That means 7 NCR2 times 5 NCR2, and that gives us 210 ways. All right, we're going to leave it there. Thank you very much, and have yourself a wonderful day.